Imagine a city that breathes, eats and sleeps, all while floating on the unpredictable waves of the ocean. This is the modern cruise ship. While the Titanic was the marvel of 1912, today's giants are 5 times larger and infinitely more complex. But how do you build a 250,000-ton mountain of steel that doesn't sink? On the Makeology, we are diving deep into the massive high-tech journey of building a modern ocean giant, from the first spark of a laser to the first splash in the sea.
Before any steel is touched, the ship is born in the digital world. Using CAD, thousands of engineers spend years mapping every single wire and bolt. They run simulations to see how the ship survives a 50-foot wave or a hurricane-force wind. In this phase, they calculate the center of gravity, the secret to keeping a 20-story tall ship from tipping over. Every millimeter is checked. A single mistake here could cost billions later.
Construction officially begins with the steel cutting ceremony. Thousands of tons of raw steel plates arrive. High-powered plasma and laser cutters, controlled by computers, slice these plates into precise shapes. This isn't just cutting, it's surgery on metal. The heat is so intense it glows white hot. These pieces will soon become the skin and bones of the ship, designed to withstand the corrosive power of salt water for decades.
Think of it as a giant Lego set for giants. Different workshops build different sections simultaneously. One team builds the bow, while another builds the stern miles away. This modular method saves years of time. These blocks can weigh up to 800 tons each. Once finished, they are moved on massive multi-wheel transporters that look like something out of a sci-fi movie.
The magic happens in the dry dock. This is a massive basin where the water is pumped out so the ship can be built on dry land. The Goliath crane is the star here. It picks up the massive blocks we saw earlier and places them with millimeter precision. Workers on the ground guide the crane using lasers. It's a nerve-wracking process. If the block isn't perfectly aligned, the entire structure of the ship could be compromised.
Once the blocks are aligned, they must be fused forever. Thousands of miles of welding seams are created. Today, much of this is done by robots for perfect consistency, but human welders still handle the most difficult corners. These welds must be X-ray checked. A tiny air bubble in a weld could lead to a crack under the pressure of the ocean. The steel cocoon must be 100% airtight and incredibly strong.
Now, we install the heart. These are diesel-electric engines, some of the largest moving machines on Earth. They don't just turn the propellers, they are massive power stations. One engine can generate enough electricity for 20,000 homes. They are placed at the very bottom of the ship to act as ballast, helping the ship stay upright. Scale is so big that engineers can actually walk inside the engine cylinders for maintenance.
To move a city, you need incredible thrust. Modern giants use azipods, propellers that can rotate 360 degrees. This means the ship doesn't need a traditional rudder. It can turn in its own length or move sideways into a dock. Each blade is made of a special bronze alloy to prevent rust. Watching these 100-ton propellers being bolted on is a masterclass in heavy engineering.
One of the greatest secrets of modern shipbuilding is that the thousands of luxury rooms are not actually built inside the ship. Instead, they are manufactured in a separate factory, complete with air conditioning, beds, and fully tiled bathrooms. This is the modular cabin method. As soon as the steel hull is ready, these finished rooms are hoisted by cranes and slid into the ship's framework like a giant game of Tetris. This ingenious method saves years of construction time, allowing interior work to happen simultaneously with the heavy steel assembly.
To keep a floating city alive, you need a nervous system more complex than any skyscraper. A modern cruise ship contains over 3,000 miles of electrical cables, enough to stretch across the entire continent. Alongside these are thousands of miles of pipes carrying fresh water, fuel, and waste. Every single connection must be airtight and triple-checked. A single short circuit or a tiny pipe leak in the middle of the ocean could be catastrophic. This stage requires thousands of specialized electricians and plumbers working in perfect synchronization.
Transforming the top deck into a tropical resort is a massive engineering challenge. Holding thousands of tons of water 20 stories above the sea affects the ship's stability. To solve this, engineers install anti-slosh tanks that prevent the water from shifting too violently during rough weather. These fiberglass water slides are engineered to be lightweight, yet strong enough to withstand hurricane-force winds and the corrosive salt air. It is the perfect blend of high adrenaline fun and hardcore engineering.
Now comes the glamour. At this stage, the ship stops looking like a machine and starts looking like a royal palace. Master craftsmen bring in Italian marble, European crystals, and exotic woods to decorate the grand dining halls and theaters. Hundreds of interior designers work around the clock, polishing every surface to perfection. From 2,000-seat Broadway-style theaters to high-end casinos, every detail is designed to leave the passengers breathless the moment they step on board.
The ocean's salt water is the ultimate enemy of steel. To protect the hull from rust and corrosion, the ship is coated with several layers of specialized chemical paint. This isn't just for beauty. These anti-fouling paints prevent barnacles and algae from sticking to the hull. This reduces friction and saves millions of dollars in fuel. It takes tens of thousands of gallons of high-grade paint and several weeks to cover this floating mountain. The most emotional moment in the shipyard is the float out. As the dry dock is slowly flooded, this 250,000-ton steel giant touches the water for the first time. Engineers watch nervously, checking every sensor to ensure the hull is perfectly watertight. Amidst the cheers of thousands of workers, the ship finally leaves its birthplace. It is no longer a construction project. It is now a living, floating vessel ready to conquer the waves.
Before it can carry a single passenger, the ship must pass its final exam, the sea trials. In the middle of the deep ocean, captains push the engines to their absolute limits. They test the maximum speed and perform high-speed J-turns to test the stability. These trials prove the true power of the engines and the reliability of the Azipod propulsion systems. Only after passing these grueling tests does the ship receive its official license to sail.
The modern cruise ship is a testament to human ambition and engineering genius. It is the result of millions of man-hours and the most advanced technology on the planet. If you enjoyed this journey into the heart of engineering, hit the like button and subscribe to the Makeology for more incredible how it's made stories. Till next time, keep exploring the wonders of making.